Hello everyone. Today we are going to discuss an important topic from 11 mathematics. The name of the topic is probability. Before that, we are going to discuss some basic terms and definitions. First of all, random experiment. An experiment is said to be a random experiment if its outcome can't be predicted with certainty. As for example, tossing of a coin, rolling a die, drawing a card from a well shuffled pack of playing cards, etc. Then we'll discuss sample space. It is nothing but the set of all possible outcomes of a random experiment is called the sample space. It is denoted by S and its number of elements are ns. As for example, in throwing a dice, the number that appears at top is any one of 1, 2, 3, 4, 5, 6. So here S is the set containing the elements 1, 2, 3, 4, 5, 6 and ns is 6. Then we will define event. Every subset of a sample space is an event. It is denoted by E. Example, in throwing a dice, the sample space is containing the elements 1, 2, 3, 4, 5, 6. The appearance of an even number will be the event E containing elements 2, 4, 6. It is a subset of S. Then we'll discuss about simple event. An event consisting of only one sample point is called a simple event. Example, in throwing a dice, sample space is the set containing 1, 2, 3, 4, 5, 6. So each of the singleton set containing element 1, 2, 3, 4, 5 and 6. They are all simple events. Then we will discuss about compound event. An event which has more than one sample point is called a compound event. Example, in throwing a dice, the event of appearing of even number is a compound event because the elements in E are 2, 4, 6, which has 3 elements. Then we'll discuss about equally likely outcomes. All outcomes with equal probability is known as equally likely outcomes. Example, when a coin is tossed, both the two faces, head or tail, are equally likely to come up. Then we'll know about sure event. Let S be the sample space. If E is equal to S, then is called a sure event. Example, in a throw of a dice, S is the set containing 1, 2, 3, 4, 5, 6 and let E1 be the event of getting a number less than 7. So E1 is a sure event. So we can say in a sure event, number of elements in E equals to number of elements in S equals to 1. Now we'll discuss about mutually exclusive or disjoint event. A and B are mutually exclusive event if A intersection B is phi. Example, when a coin is tossed, the event of occurrence of a head and the event of occurrence of a tail are mutually exclusive events. Now we'll discuss about independent or mutually independent event. Two or more events are said to be independent if occurrence or non-occurrence of any of them does not affect the probability of occurrence or non-occurrence of the other event. Now we'll discuss about exhaustive and mutually exclusive events. Let S be the sample space associated with a random experiment E. Set of events E1, E2, En are said to form a set of mutually exclusive and exhaustive system of events if E1 union E2 union union En is equal to S and Ei intersection Ej is equal to phi for I not equals to j. Now we'll know about complement of an event. Let S be the sample for random experiment and E be an event, then complement of E is denoted by E dash, where E dash occurs if and only if E does not occur. Now we'll discuss about classical probability. Let there be an exhaustive, mutually exclusive and equally likely cases. Out of this, let M be favorable to the happening of an event A, then probability of occurrence on event A denoted by PA is defined as PA M by N. Now we'll discuss about one of the important topic called axiomatic approach to probability. Let H be the sample space of a random experiment. The probability P is a real valued function with domain is PS, that is power set of H, and range is the interval, closed interval 0 1, so as to satisfy the following axioms. Axiom 1, for any event E, probability of E is greater than equals to 0. Axiom 2, probability of H is equals to 1. Axiom 3, when E and F are disjoint events, then probability of E union F equals to probability E plus probability F. Now we'll discuss about some theorems on probability. First theorem, in a random experiment, if H be the sample space and A an event, then probability of A is greater than equals to 0. Probability of null set equals to 0. And probability of sample space is equals to 1. Now theorem 2, if A and B are mutually exclusive events, then probability of A intersection B equals to 0. Now theorem 3, if A and B are mutually exclusive events, then probability A plus probability B equals to 1. Now theorem 4, if A and B are mutually exclusive events, then probability A union B equals to probability A plus probability B. Now we'll discuss theorem 5. For any two events A and B, probability of A minus B equals to probability of A minus probability of A intersection B. Now move to theorem 6, addition law. For any two events A and B, probability of A union B is equals to probability A plus probability B minus probability of A intersection B. Theorem 7, addition law for three events. If A, B, C be three events associated with a random experiment, then probability of A union B union C equals to PA plus PB plus PC minus PA intersection B minus B intersection C minus PA intersection C plus PA intersection B intersection C. Corollary, if A, B, C are mutually exclusive events, then probability of A intersection B equals to probability of B intersection C equals to probability of A intersection C equals to probability of A intersection B intersection C equals to 0. Also, probability of A union B union C equals to probability A plus probability B plus probability C. Theorem 8, for each event A, probability of A bar equals to 1 minus PA, where A bar is the complementary event. Theorem 9, if A and B be two events such that A is a subset of B, then probability of A is less than equals to probability of B. Theorem 10, if A is an event associated with a random experiment, then 0 less than equals to PA less than equals to 1.